like fixed over 0.
And since one of them is infinity, we know it diverges.
Yeah, this should diverge. Just we need to double check to make sure there's nothing else happening out here, but there's not. So like let's just say out here was some t's or something and this went to 0, right? Like what if that went to 0 and this went to infinity? That would be an indeterminate form. So, but it's not. This is all we have going on. It's going to infinity.
So if that were the case, would we put indeterminate? Or would we still put...
No, we've got to go, you know what? There's one coming up just like it. Yeah. So we'll have to address that. So stand by. Stay tuned. All right, so this one, 1/4 times negative infinity. This whole thing right here is headed to negative infinity. And then here, who cares? -1/4 times natural log 3. That's just a number. That's gonna blow up. It's going to become a big negative number that diverges. All right. Look at that. We had to do partial fractions here. How y'all feeling about this? That good, huh? All right, how about this one? Now look, before we do this one, let me do one that's going to be a lot quicker before this one. How about this integral? Integral from, let's say, -1 to 1 of 1 over x squared dx. So I'm going to show you a mistake. I don't like showing mistakes, but I'm going to show you a mistake. A mistake would be like, oh, well, I know the antiderivative of that. That's -1 over x. We did that earlier today. Then I'm just going to go -1 to 1, which means I'm going to do parenthesis. So you have to think you're in the middle of a test, right? And you're like working through this and you're not paying attention. And this happens. You plug in 1, you get -1 over 1. It's -1. You plug in -1, you get -1 over -1. So what do we get here? -1 minus 1 again. It's -2, right? That's what you get. It's totally wrong. Why is that totally wrong? Because there's a discontinuity. This thing is not defined at 0, right? You can't plug 0 into this. But your interval includes 0, right? 0's in here. You have to account for that. If you do not account for that, you're going to get something here. It's going to be complete rubbish, all right? So that's wrong. This next example is another illustration of this, all right? But this one's just easy to integrate, so it was quick and easy to show you what happens. That one's a little harder to integrate. So, all right, so here's our function. Our function is x over cube root x minus 4. And our interval is from 3 to 5. Are there any issues that we have here? At 4, right? At 4 we get 4 minus 4 is 0. Cube root of 0 is 0. Division by 0. So that is a problem. Are there any other places where we have issues? Where do you have an issue? 4, yes, but are there any other places?
What was the question?
I'm just wondering if this is the only place that that function ever has a problem.
Between 3 and 4. Anything between 3 and 4.
At 0?
Well, this is a cube root, right? Cube roots, you can do cube roots of negative numbers, so you don't have to worry about that being negative, right? Right? If this under here is negative, that's okay. The cube root of a negative number is defined. The 4 gives me division by 0, right? That's the only number that's going to make the bottom 0. There's no other number that causes any problem. Some people will say 0. But if I replace that with 0, what do I get? 0 on top, 0 here, 0 minus 4, -4, cube root of -4, I don't know, some number, but it's not 0. So you don't get division by 0, you get 0 over number That's just 0, so that's not a problem. You can get 0 to come out of a function. We just can't have undefined, right? So this is the only place that causes a problem. Yeah? Pardon? Now we're going to split this in two. All right? All right, so we're going to do this. We're going to take that original integral, but instead of going from 3 all the way to 5, we're first going to go from 3 to 4, right? And then add to that the integral from 4 to 5. Now, if one of these diverge, the whole thing's over, okay? It all diverges. But if they both converge, then the answer is that it converges. So for divergence, you just need one of these to diverge. But for convergence, you actually have to have both of them converge.
Well, it could be 1 and 1.
Pardon?
Well, no, it can't be. Never mind.
1 and 1?
Like 1 diverge and 1 converge.
Oh,
You already said it.
yeah, no, yeah. If you have a mixture of both, then it's diverge. How about we take care of this integration? Aren't we going to need this integral, like the antiderivative? Before I do any limits or anything or rewrite it, let's actually take care of the integral. So here's my integration. Okay. What are you going to do this integration? U sub? What's your u going to be? X minus 4. Du dx, right? And when you rewrite this, you're going to have to rewrite x. So you solve this for x. X is u plus 4. Agree? All right, so this new integral becomes x, which is u plus 4, over cube root of u, and then du. So that's a pretty clean substitution. There's no constants that had to come out or anything, or negatives. Different ways you can do this. I'm going to do it this way. I'm going to write u over u to the 1/3 plus 4 over u to the 1/3. So I said, since I've got two terms up here and one down here, I can split into two fractions. Cube root of u is u to the 1/3. So you see that? And then now I'm just going to take each of those, just clean them up, a little bit of algebra here. U to the 2/3 plus 4u to the negative 1/3 du. Then at this point, power rule. So the antiderivative of u to the 2/3 is? 3/5 u to the 5/3. That's the antiderivative of this. Let me just bring the 4 for the ride here. Here's 4, but antiderivative of u to the negative 1/3. So you add 1 to that, you get 2/3, 3/2 u to the 2/3 plus some constant. We can do some additional cleaning up here, and I can replace my u's. So 3/5 u, which was x minus 4, to the 5/3, plus 6 times x minus 4 to the 2/3 plus c. That's our antiderivative. I'm going to need that, right? Both of these integrals require the same antiderivative. I just want to make sure that everyone's on the same page with me here. Yes?
Can you leave out these C's?
Can you do what?
Can you leave out the C's?
Can you forget these C's? Yeah, sure. I wouldn't, but you can. No.
I mean, like on the exam.
That's okay. I won't take off. Now, if it's a definite integral that I'm asking, if it's an indefinite integral that has no limits of integration, then I'm going to want the plus c. But in an intermediate step that you're just trying to find it, don't worry about it. All right, erase this. Come back over here. Let's finish this up. Now, I'm going to have two separate integrals that both have problems. They both have a problem at 4. So I'm just going to highlight here this 4 and this 4 where we have the issues. And so the first one, I'm going to set up a limit, right? And I think I'm going to come up here and do it. So this right here becomes the limit as t approaches 4, right? From which side? The left side. So with a little negative of the antiderivative of this, right? Which is right there. 3/5 x minus 4 to the 5/3 plus 6 times x minus 4 to the 2/3 evaluated from 3 to t. Yeah? Plus, now this one, which is another limit, right? Different limit. It's the limit. Now, I probably should not use t again. So, r, is that okay? R? R is approaching what? 4 from the right side this time. And then the same thing. We have to write all that crap. I can say crap. That's not a bad word. Some people have been like texting me and trying to catch me with my cussing on like old videos from like, a year ago, like 2 years ago, old classes or something. That doesn't count. It has to happen like in here. And you'll have to catch me. Live in class. You can't catch me on the video later.
I've got it. I write it down.
Yeah, okay. All right, so where are we at?
You cursed twice.
What goes here? T to 5. All right, now the fun time. Now I'm going to have a set of brackets and 2 parentheses here, another bracket and set of parentheses here, and limits in front of both of them. Yeah, remember, we talked about trees. You don't worry about it, okay? You don't worry about it.
Yeah, we're going to replace the trees.
Okay, so here are my sets of parentheses. See if I can squeeze that in there. First, I'm going to plug in t, right? So I'm just going to rewrite all this, replacing all my x's with t's. Wow, I'm really going to have to squeeze that in here. 3/5 x minus 4, not x, sorry, t minus 4 to the 5/3. I think I'm going to need to erase that. Then plus 6 times t minus 4 to the 2/3. That's what I get when I plug in t. Then I plug in 3, right? So minus parenthesis. Let's talk about this 3 that goes in. Some interesting stuff's going to happen here. 3 is going in here. So 3 minus 4, -1. What is -1 to the 5/3? That's the cube root of -1 to the 5th power. Or you could also say the cube root of -1 to the 5th. It doesn't matter what order you do those in.
Just -1.
But what is it?
-1.
-1, right? Cube root of -1 is still -1, and then -1 to the 5th power is still -1. So when I plug in 3 right into this and do all that 5/3 power, I get -1, then I multiply times 3/5. So how about just minus 3/5 there for the first part? The next one, -3 comes in here. 3 minus 4, -1, and then look at that 2 up there. That 2 means squared. So you get +1. And then cube root it, you still have +1. So be aware, -1 to the 2/3 is -1 squared and then cube root. So you square the -1, get 1, then cube root, that's 1, not -1. See the difference between these two? The squaring makes the negative go away. So that's going to be a 1 and then the 6, so just plus 6 here. Close that off. I still have to take a limit, okay? I haven't taken that limit yet. When I take the limit, yes, it will be 0. But we still have to do this one, so I'm just going to write this one down now. So plus limit r goes to 4 from the right, bracket, parenthesis. Now, what's going in first? 5? Ooh, this should be nice. Check it out when we plug in 5. That's 1. 1 to any power is 1. So I'm going to get my 3/5 again. And then plus, same thing here. 1, so 6 plus 6. That one wasn't so bad. Minus, now we plug in t. So 3/5 t minus 4 to the 5/3 plus 6 times t minus 4 to the 2/3.
It should be R.
Yes, it should be r. Thank you. R. And then close bracket. Those are r's, not t's, because our limits are. Now let t go to 4. That's going to go to 0. 0 to any power is 0. That's going to go to 0. So 0 to any power is 0. So that's all gone, right? This is all going to vanish to 0. And same situation here, right? When we let r go to 4, those are going to go away.
Even though it's a positive four?
Is what now?
Even though it's a positive four, doesn't matter?
What's a positive 4?
Because if it's plus.
That doesn't mean it's a positive 4. This is 4 from the right side. It's still headed to 4, right?
So then you just.
All I'm left with are some constants, right? So let's distribute the negative through here. We should get that this is equal to, and no more limits, right? I've taken all my limits. So 3/5, take away 6, and then here, plus 3/5 plus 6. 6 is cancel. 6/5. Converges. That converges. So here's a little lesson here. What if you had messed up on the test and you didn't catch that there was a problem at 4? Okay, let's just say you didn't catch that there was a problem at 4. Then let's see, you would have this, wouldn't you? You would have, this is the antiderivative, right? That's the and you would be plugging in from 3 to 5, wouldn't you? Yeah? Okay, what happens when you plug in 5? When you plug in 5, you get, what, 3/5, right? Because that's a 1. You get 3/5 plus 6. So this would be 3/5 plus 6. And then you'd plug in 3. And we already said when we plugged in 3, that was negative 3/5. And then when we plugged in 3 here, because we squared it, that would be plus 6. And you would get, let's see, what do you get here? How'd that do?
They do cancel.
So what do you get?
0.
No.
No, you get 6.
You get 6/5. But I took off like 5 points. And you're all upset. I'm justified. Are we clear on that? I'm justified. You missed a whole bunch of stuff that you should have had, that you should have looked at. And it is purely coincidental that this gave you the same answer. In general, that won't happen. So I will take off if the procedure's wrong. All right? Just be careful. All right, the next one I'd like for you to work on. I'm going to give you some time. I want you to work together, all right, help each other out. Yes?
I have a question real quick. What would
Yeah.
be just the area between 3 and 4?
Just the area between 3 and 4. Where was our 3 and 4? Was it this one? It was this one, right?
Yeah.
Then it would be that right there.
Would that be negative?
You would have negative. Well, we haven't graphed it. We didn't graph it. Do you want to see the graph?
Oh, so would that just mean that the area is under the curve?
Yes, but I mean, I don't